Hey guys, we are going to talk about our Chapter 1, Section 3, which is distance between points. We'll look at distance on a number line and then also in the coordinate plane. We'll also look at midpoint on the number line and in the coordinate plane. We'll do half of the video just talking about distance first, and then the other half will be midpoint. Alright, so first, the distance between 2 points. We're talking about the length of a segment, and the 2 points would be the endpoints. You need to add this definition for the distance formula to your definition section in your notebook, and we'll have a notebook check soon. The distance between 2 points is the absolute value of the differences between their coordinates. So let's go ahead and draw a number line since this says on a number line. And let's find the distance between negative 4 and 1. Actually, I took that off, so let's go 2. That'll be even better. Alright, so to find the distance between those two, we can count, but we can also take the absolute value of their differences. Difference means subtract, so notice I put a subtraction sign here. So negative 4 minus 2. And we can change this to negative 4 plus negative 2, which is absolute value of negative 6. Notice I just keep bringing those absolute value bars down until the end. I have to do the inside first. The absolute value of negative 6 is 6. When you take the absolute value of a number, it's always positive. So if it's positive inside, it's okay. It's going to stay positive. If it's negative, it becomes positive because we're talking about distance from point to point. Distances will be positive. Alright, let's keep going. Now it's your turn to try this one. We want the length of segment QR, so we want this length right here. So use absolute value and subtraction to do that. So find the difference between negative 2 and 3. Alright, now that you've done that, you should have written down negative 2 minus 3, which would be negative 2 plus negative 3. Or the absolute value of negative 5, which is 5. By the way, you could have written those in a different order. You could have said 3 minus a negative 2. That would be fine as well. The absolute value of 5 is 5. So you'll get the same answer. It doesn't matter which way you write that. Okay, distance between 2 points in the coordinate plane. This also goes in your definition section. If P has coordinates x1, y1, and Q has coordinates x2, y2, then to find the distance, I'm going to go ahead and draw a little triangle over here. So here's the coordinate plane, xy, and we have points x1, y1, and x2, y2, and we want this distance. Well, we will find the vertical distance and the horizontal distance, and this is a right triangle, so we'll actually use Pythagorean theorem, a squared plus b squared equals c squared. So this distance is the difference between my x's. So this distance is right there. So we'll do x2 minus x1. So I'm going to find x2 minus x1 squared plus this distance right here, y2 minus y1 squared, and I want the square root of that. Again, that comes from the Pythagorean theorem, which says a squared plus b squared equals c squared. I don't know why I wrote it out. Let's try to get rid of that because I don't want it there. I'll show you where I want to put it. A squared plus b squared equals c squared, where a is a leg of the triangle, b would be the other leg, it doesn't matter, you can switch those, and c is the hypotenuse. So this length would be the difference, just like we found on the number line, the difference between those two. And b is the difference between those two. Alright, so let's get an example, and then I'll let you guys work one. So let's say that our points are 2, negative 1, is point A, and point B is -3, 4. All right, I like to label these x1, y1. It doesn't really matter which way you do this. x2, y2. So I want the square root of -3 minus 2 squared plus 4 minus a -1 squared. -3 minus 2 is the same as -3 plus -2. So -5 squared plus 5 squared, because this is 4 minus -1. We have to do these first, so -5 squared means -5 times -5, which would be 25. 5 squared, 5 times 5 is also 25. Then add those together, that's the square root of 50. All right, we can simplify this because we know this is 25 times 2. The square root of 25 is 5, and then the square root of 2 has to stay in. So remember our little factor tree that we have seen before. I have a group of 2 5s, so it's going to come out as a 5. So this length, C, is 5 times the square root of 2 for the points 2, -1, and -3, 4. All right, so if you want a picture of that, we could sketch that real quick. 2, -1, -3, 4. So we found the length of that segment from point A to point B. And we did that by finding the lengths of the legs. So, good job on that, guys. All right, that's part 1 of our recording.